we've actually looked at the concepts that we need to do already. So I'm just going to add some new terms. So the first one is the confidence level. So typically that's going to be something like 95%, it might be 99%. It would be how confident we are of something. And the example would be the past paper question that we looked at in probability, where we had a manufacturer of a component. So a component, and say the size was 20 millimeters. So the mean size, or I'll just put in average. So the average size was 20 millimeters, and the standard deviation was 0.1 millimeters. So every component is not identical. You try and make it standard size, but there are little fluctuations. So in the end, you're making some which are slightly bigger, some which are slightly smaller, and that's described by the standard deviation. And then from that past paper question, we also had the tolerance, and say that was something like 0.25 millimeters. So that tells us, how much variation we're allowed, how much variation before the thing breaks. So then we use the table book, and there we could look up what the area was. We could see what the probability, so it was normally distributed in the question. The components were made with an average size of 20 millimeters and a standard deviation of 0.1 millimeters, and were normally distributed. So what that tells us, and what that allows us to do using the table book, is see what's the probability of the component being bigger than Z standard deviations away from the mean. So we know the average size is 20 millimeters in this example, and then we go, how many standard deviations away am I interested in? So our standard deviation is 0.1 millimeter, the tolerance is 0.25, so then the Z that of interest is 2.5. And when we look up the table book, that tells us what the probability of the component being bigger than the tolerance. So, the ones that would be rejected. And then in that question, we also had to remember that, well, it's symmetric, so components could be bigger than, or could be more than 0.25 millimeters bigger than the average, or they could be too small. And so we had to double the probability. So have to take care whether can fail due to being too small and too large. Which we looked at in that question. Another point that we wanted to make was that of a confidence interval. So it's the width. So I could say, oh, I want a confidence level of 95%. Then using the tables book, you can work out, okay, if I want a confidence level of 95%, then I want 2.5%. I want that to be 2.5%. And so I look up in my tables book, what does Z have to be in order for the tail to be 2.5%? So I'm putting that in steps. 1, look up what Z has to be for our confidence level. And then once we know what Z is, if we know that the tolerance is, say, 0.25 millimeters, then we can also describe this by using a confidence interval. So I'll write that over here. It's a bit crowded. So that would be the mean plus or minus Z standard deviations. So it might be something like 19.75 to 20.25 millimeters, using these numbers from the exam type question. So if the mean was 20 millimeters and the tolerance was 0.25 millimeters, then my confidence interval would be 19.75 to 20.25. But then you'd have to look up in the tables book what the appropriate probability is. So if the standard deviation is 0.1 and the tolerance is 0.25, that means Z is 2.5, and I can look up what that probability is. And since we can reject things for being too small and too large, if that was 2.5%, I don't know what that number actually is, then I'd also have 2.5% from the cases which were too small. So say that was 2.5% also. And so if I knew that there was 2.5% of cases that were too big and 2.5% of cases that were too small, well then I'd know that my confidence level was 95%. Now, unfortunately, I know that that isn't actually the case, because I know that when Z is equal to 2, the confidence level is 95%. So I should have looked up what the number was, but basically that's the process that you go through, that you look up in the table book, and you can see, given your Z, what that probability is. Now, then you have to check whether your thing can be whether you're interested in both tails or only one. So then, if this would be called, actually, that's actually the final thing I wanted to say. So this is also known as a p-value. So if I say the p-value is 2.5%, then that's what it means. That the cases which are rejected, while the confidence interval is 1 minus twice the p-value if it's two-tailed, or 1 minus the p-value. So that's all that I wanted to say on this topic. It's just familiarity with the jargon, confidence interval and confidence level, and just doing some practice questions, because there's not many variations really. So basically just knowing the past paper example that we did when we looked at probability pretty much covers what you need to know.